Visitors from outer space. They crash land without warning and can lie buried for thousands of years.
How could I possibly have missed that?
Geoff Notkin and Steve Arnold live to unearth these space rocks. They are the Meteorite Men. On this adventure, the guys get special Park Service permission to hunt Arizona's Gold Basin for a famous 15,000-year-old fall.
The restricted area. Full steam ahead!
They take to the waters of Lake Mead to get to an untapped area that could hold the big space rocks that have eluded hunters for years.
My biggest concern is how steep the cliffs are, and if we can even land a boat this big.
One of our dreams has always been, can we get onto the bluffs where probably no one's ever looked for meteorites?
Jim kept this really secret. There's a wealth of information here.
With just 72 hours to hunt, they hit the desert armed with a one-of-a-kind map. If they can find something big here, their lives will never be the same.
Got one!
Great to be back in a classic American strewn field.
Definitely.
Geoff Notkin and Steve Arnold are on the hunt for meteorites in Arizona's Gold Basin, 2 hours east of Las Vegas.
This is one of the greatest, largest meteorite falls in all of the world.
We're not looking at one big meteorite that just hit the Earth. We're looking at an event that scattered thousands, maybe tens of thousands of rocks over a gigantic area. Must have been one heck of a fireball.
That fireball streaked toward Earth 15,000 years ago, raining stone space rocks laced with iron down over an area of more than 140 square miles. Steve and Geoff aren't here for just any Gold Basin meteorites. They want the big ones. Big is something Geoff and Steve know a lot about. Over the years, they've literally discovered tons of meteorites. In 2005, Steve used old maps and new technology to unearth a 1,400-pound meteorite buried in a wheat field in Kansas. It's valued at roughly $1 million. But at Gold Basin, the stakes are different. The overwhelming majority of stones are smaller than a ping-pong ball. Of the thousands of rocks found, only a few bigger than a baseball have ever been recovered.
So here's the road we came in on.
For this hunt, the guys feel they have a big advantage. This is the original map from the man who discovered this strewn field in 1995. Geoff's close friend, Professor Jim Kriegh.
Hold it up for the camera and smile.
Jim Kriegh was a retired University of Arizona engineering professor and something of a mentor to me. After he retired, he took up gold prospecting as a hobby. And up here at Gold Basin, he accidentally discovered one of the biggest meteorite-strewn fields in history.
Just from the sound, that's got to be one. Pretty good size.
Jim put together a small team that precisely recorded every find.
It's a little thin one. Yeah, I imagine 100 grams or so anyway.
A scientist from the University of Arizona had come to the Gold Club and told the guys, when you're out with your detectors, keep your eyes open for meteorites. Well, Jim Kriegh did. We basically mapped the field 15 miles by 5 miles. The university wanted the strewn field established, a map of the area, before the public was allowed to come in. So for 2 years, they asked us not to say anything. We'd pick different areas to hunt and ascertain they were there, then pick another area. It's just really interesting to find something that, you know, fell from outer space and has been just sitting here 15,000 years.
When news of a new meteorite discovery gets out, meteorite hunters tend to descend on the spot like a plague of locusts, and Jim knew that would happen.
Jim kept the treasure trove secret for 2 years while he and his crew diligently compiled data on the meteorites and the fall that scattered thousands of tiny pieces across the landscape. Geoff and Steve now have Jim's treasure map. All the finds are marked, making it one of the most precise strewn field maps they have ever used.
Jim kept this really secret, and even though he and I were close friends, I only ever saw this map once while he was alive. There's a wealth of information here.
Once they got the map, it took months to get the special access they needed to hunt here.
2 pieces were found right there, probably on the same day as number 17.
This is federal land, and it's tightly controlled by the National Park Service. Although there are some parts of Gold Basin still open for meteorite hunting, the best areas are completely off limits, and the fines are harsh.
Just having a metal detector can get you a $5,000 fine and a prison term of up to 5 years.
Ranger Andrew Munoz oversees the Gold Basin area, and Eric Cotto is assigned to monitor their hunt.
So we're interested in hiking on both sides of the road, roughly in this area.
Time's very limited. We've just got a little window, and we really want to make the most of it. We've got all this permission and all these great things, and if we don't find anything, would frankly be very embarrassing for us.
Geoff and Steve's permit allows them to hunt for just 72 hours, and they have a vast stretch of sun-scorched desert to cover.
We've got a big strewn field here at Gold Basin. There are rocks over many square miles. And so we've got to choose where we're going to hunt. So here we are in the middle of the strewn field. And here we're looking for smaller meteorites, maybe 1 inch across to 2 or 3 inches potentially.
Location number 1 is in the restricted area, where people can't hunt without a permit. The guys have high hopes.
Where? Gold Basin, the famous.
The restricted area.
I am not going up in that area without my snake gaiters.
Because in these parts resides the Mojave rattlesnake. If you get bitten by one of them out here, it's pretty much all over.
Don't forget the sunscreen.
It's not even started.
It's kind of annoying if you get to the top of the hill and go, oh, I forgot my magnet, or I forgot my water, or my spare battery. My GPS, or my spare GPS, first aid kit.
What's taking him so long?
Okay, I think we actually are finally completely ready.
Meteors, when they break up in the air, the rocks will continue to fly, but then they slow down to a point where they burn out, and that's going to be from 5 to 10 miles up, and then they start in a free fall coming straight down.
The science of how meteorites fall is based in physics.
So when you have a meteorite like Gold Basin, it entered the atmosphere as a single piece, maybe 10, 15 feet in diameter. Essentially, the larger pieces travel, of course, further as a result of greater momentum, and the smaller pieces tend to fall a little bit closer. You can learn something about the direction from which the meteorite was coming in and kind of forces that it underwent, so just sort of the breakup forces that resulted in the formation of that strewn field.
Freshly fallen meteorites generally have a thin black fusion crust, a scar from the inferno created by atmospheric pressure and friction as the alien visitors pass through the Earth's atmosphere. Once on the ground, exposure to moisture and oxygen take a toll, especially after thousands of years.
These meteorites are stone meteorites, but they're also old and weathered, so we're looking for earth tone against earth tone. It's kind of a Where's Waldo, trying to find that rock. But we know they're here. It's just a matter of getting a little bit lucky. So you don't get lucky unless you keep moving and keep looking.
But it isn't their eyes that Steve and Geoff must rely on as much as it is their ears. These 4.5 billion-year-old meteorites are stone, but they're rich in iron nickel, which can be picked up by a metal detector.
The detector that I'm using, called the F75, it's one of the most powerful and sensitive metal detectors for its size. The control box generates an electromagnetic pulse. When those electromagnetic pulses encounter a metallic object, they create an echo. So this is the kind of sound we're looking for. That's the detector reading the metal in my boot. It's that sensitive. The Gold Basin meteorite's a very old fall, and it's an L04 chondrite, and the L stands for low, meaning low iron, and will generate a very weak audio signal on the detector. I'm using a pair of headphones to improve my odds, plus then I can't hear Steve bellowing at me.
Wow, he can move when he wants to.
It's 9:45 in the morning, and the desert is heating up fast. There's no hint of a breeze and no shade in sight.
The hunting technique that I'm using today is a bizarre mix of logic and intuition. The Gold Basin meteorite fell 15,000 years ago.
It therefore makes sense to look on old surfaces. If you look in washes or in rock slides, any meteorites that may have been on those surfaces have probably been carried away and buried. So what I've been doing is working my way across the ridges. So that's the logic part. The intuition part is that in your heart, you just go, I should be over there. I should be on that hill, no, that hill. And there's something that just draws you.
Hey, I'm starting to sweat. Didn't know there was sweat in the forecast. That's sick. That's what we want right there. But one that's a meteorite, one that's real. Something that big would be nice, though.
3.5 hours into the day, Geoff gets a powerful hit.
That's it right there. Steve, I've got one!
Got one. He got one.
They're often together in a small cluster, so I want to have him come over and search with me.
Now I got to go over and congratulate him.
Steve and I both think it's likely that the meteorite traveled roughly south to north, which would be over our heads in this direction.
Come on. Big one. Big one. Help me save face here.
There could be tiny pieces way down there and big, big pieces way up there that have never been found. This strewn field could be 20 miles long for all we know. There's a piece right here on the surface. I haven't disturbed it yet.
So what's all this yelling about?
I found one.
Oh, yeah. Something there.
The first test, does it stick to a magnet?
That's a pretty good size one.
Not too bad.
The powerful rare earth magnet on Geoff's pick is their field test for meteorites.
I just had a good feeling about this ridge. It just looked nice. It looked like a place where meteorites might live. I probably was only hunting for 15 minutes at that spot, and I found one nice little piece right on the surface.
It's a fragment, though. I mean, it's broken. It's got
Right.
broken faces. So I was really good. I didn't do any searching after I found this piece.
Okay.
What are you getting? No, that's...
Yeah, it is.
Oh, my God. See how good I was? I should have found that one. It's too funny.
Is mine bigger than yours?
Yeah, that's so not fair.
Well, you know.
Mine's nicer.
It's a teammate thing.
Geoff's find is 35 grams, worth around $100. Steve's is 57 grams, worth about $175.
I could have been mean and just, Steve's over there. Could he find all the bits? But we try to be nice to each other most of the time.
Geoff found the first one, and that's cool. I mean, we're a team, and it was good. And if he hadn't found his first one, I sure wouldn't have found my first one because it was only 12 inches away. Let's keep hunting. Oh.
Are you kidding me?
Oh, my goodness.
Okay, I spotted that one by eye. Did you see I didn't even have my detector on?
I guess we're not leaving here for a little while.
Down while we were talking. Wow. These meteorites are often found together in small groups or clusters. We have a very large body that explodes and breaks into smaller pieces and smaller pieces as it's traveling through the atmosphere. They keep traveling together, and maybe 4, 5, 6, 7, 8 pieces land very close together in a small area. They might still be sitting where they landed 15,000 years ago, or they may have been uncovered by wind blowing the topsoil and sand away. The ground here on this ridge is known as desert pavement. The rocks that are left behind are a kind of hard jigsaw puzzle that have been baked by the sun and blasted by the cold. So it's a very old, resilient surface.
All right, it's GPS time.
The guys mark the exact location of each of the 3 meteorites. Every new find adds more data to the original map created by Jim Kriegh.
And a little photo up.
Not to mention that these 3 are worth close to $400.
Well, this is going quite well. And remember, where there's one, there are more. Hopefully. Hopefully, positive thinking. One of the best things that ever happens to us is when we get in this groove, you're in a good zone, and there's one every few minutes. You just gotten over the excitement of finding one, and boom, there's another one. And that is what makes it all worthwhile. Guess what?
You found a meteor wrong?
I found a meteorite. This really looks like another piece of the one that you found.
Okay.
It's a rounded fragment from a much bigger stone, which would explain why there are pieces all over the place here. Doesn't that look like... It looks really similar to that fragment.
I don't know.
Oh, you're such a pessimist.
It's not exactly a contest. We're playfully competitive, but at the end of the day, the best thing is if we've both found something.
Something's reading in there.
Steve's got a strong hit, but there's no rock visible on the surface.
I don't think so.
Whoa! It is. I
Holy cow.
so cannot see.
Holy cow.
I couldn't spot it. My magnet missed it. And I was just picking it up, you know, running handfuls of stuff over. And I got the handful with the screaming. And slowly dropping it, and that's what was left.
So it was buried?
Yeah.
We did a very detailed, methodical search, and we turned up quite a few pieces in close proximity. It felt really good, and then you just kind of get this rush and go, oh, thank God we actually found something. It's not a complete washout.
Arr.
You maniac. How about this? All right, it's a sensible one now.
In 20 minutes, the guys bagged 5 meteorites worth around $600. But there's a hitch. Their permit requires they donate all finds to a public meteorite collection. In this case, the MONRAD Gallery at TCU, Texas Christian University.
It's a tad bit frustrating knowing that we got to get rid of them, but if it wasn't for the opportunity to come out here and to hunt with the special privileges, we wouldn't have found them anyway. So it might not be as bad as some people might have with parting with them. Well,
who's parting with them? We just won't own up to finding them. I'm just kidding. We can give up a few meteorites for the privilege of hunting out here.
And we can always go to TCU and visit them.
Having successfully searched the part of the strewn field where all of the finds were made, Steve and Geoff head off to...
Check it out.
The northern border of Jim Kriegh's map of recorded finds, at the edge of Lake Mead.
I think we've gone as far as we can go.
Oh, this is it. End of the road.
Hopefully not the end of the strewn field, though.
No, they can't. There's no way.
It seems inconceivable that with a strewn field that's over 10 miles long, that they didn't just carry right on over to the other side.
Right.
As the fireball broke up, the smallest pieces fell first, raining down over a huge area. Flight dynamics dictate that larger pieces must have continued on due to mass and inertia, landing farther away, possibly on the mesas on the other side of the lake. The guys have been dreaming for years about the big rocks they think continued across the lake, an area where no one's allowed to hunt and where the finds suddenly stop on the map.
What we really want to do is think big. We're going to get up to the top of those bluffs, those mesas, and they're going to be big Gold Basin meteorites sitting up there. That's what we're hoping for. That's the undiscovered country up there, and it's calling us.
Jim Kriegh, their friend and the man who discovered the Gold Basin strewn field, never got the chance to hunt the bluffs on the other side.
It must be nearly 10 years ago that I stood on the south shore of Lake Mead with Jim, looking across, and he was going, I know there are meteorites up there, I know they're up there, and I've always wanted to go up there.
Day 2. Less than 48 hours remain on their permit to hunt. Steve and Geoff have come up with what they hope is an ingenious plan to get to the mesas on the north shore of the lake. Location number 2. The untouched area of the strewn field that could be home to big space rocks.
Full steam ahead!
It's a big houseboat they dub the USS Meteorite 1.
We're cruising. It's a beautiful day for finding meteorites.
past these flat-top mesas is the area that I think will be due north of the strewn field that Jim mapped. My biggest concern is how steep the cliffs are, and if we can even land a boat this big in there.
No
But
kidding.
the only way to figure it out is try, and it's a bit of a dream come true for me, attempting this landing.
The guys look for the fastest route up the mesas to location number 2.
We got 3 ways. We can go in Burro Bay, Little Burro Bay, or come all the way over to here.
We should try a landing here
Okay.
in the little bay. If we can make a landing there, we're so much closer to the center of the strewn field. And if we fail to make a landing, we'll go into the big inlet.
Right, and we'll go up.
Very good. Can you see into the water? Does that go straight down?
Yeah.
Pulling into Little Burro Bay, Geoff realizes it's a tricky docking point for their 50-foot houseboat.
All right, a little closer.
That's a lot easier said than done with a big thing like this.
Little Burro Bay. We want to get right there. Right there. I don't know if it's even possible.
If they can scale these steep cliffs, they'll be at location number 2 in no time.
Trying to keep us kind of stationary here, but we keep drifting.
Geoff, I don't think this is doable.
I did hear Steve, but I'm really focused on trying to keep the boat in one piece at the moment.
If you wreck the boat, we're gonna be stuck here.
Damaging the boat on the rocky shore could cost them hours they don't have.
Do the one forward and the one backward and turn it on a dime. I have to be careful, because if I make fun of him, he'll just leave me here.
It's pretty well sucked in here now.
Whoa. Good thing I'm part billy goat.
What's your report?
Oh, I think it might be doable, but it's just gonna take forever.
That's a hell of a
And it's
climb up
loose.
there.
It
Yeah,
is
I
really
don't.
loose.
I don't think we should. It's too risky.
Those are some wicked canyon walls there. They're pretty, but they're not to be hiked on. I think we should check the other one out.
Okay.
The guys are forced to abandon Little Burro Bay and head for a landing spot farther from the area they want to hunt.
1 finger is 1 mile. 1, 2, 3 miles in would probably be the target. Do you want me to scout for
Yeah, it's probably a good
sandbars?
idea, because I saw some rocks back there.
Pull up a little bit closer. Where we were before, this looks like this is what it would have looked like a long time ago.
Yeah, it does look like a very old surface at the top. I think it's probably fruitless to search anywhere where the white layers are, because that's been submerged for who knows how many years.
This surface over here, there actually could be some meteorites on it.
This slope,
Yeah.
the gentle slope,
They filled this up, what, 70 years ago? It's been underwater for a little bit, but this looks like a really old surface over here.
it does, but would a meteorite decompose 80 years underwater? I would think so.
Meteorites don't favor some places on Earth over others. It's just that, 70% of our planet is water. A lot of meteorites probably fall in the water. And so the minerals and the chemistry that makes up these meteorites is adversely affected by all of the water and moisture, and basically degrades the meteorite to a point where it does not, those meteorites don't actually preserve their original composition.
Work your way a little closer. We'll see.
I don't want to take this big boat any closer than this.
Now he's scared to get close to the edge. What we'd be looking for below the waterline would be something that'd be a lot more rusty. If the meteorite's got iron in it, it's been submerged for 70, 80 years, it's gonna be real rusty.
The guys don't have the gear or the time to search the vast submerged areas. With only 36 hours left on their special permit, they continue on to Burro Bay. Burro Bay makes for an easy landing, but now the guys face more than a 3-mile hike uphill to the strewn field.
Are you seeing bottom?
Nope.
Good.
Keep going, Geoff.
Look at that, driving the big boat right up onto the shore without sinking anything.
Time to pack on the gear, including Geoff's trusty snake gaiters.
The man who does the boat repairs was telling me that he's seen mojave rattlers out here. They have a deadly neurotoxin, and if we need a medevac, it takes 2 hours.
And didn't he say something about you only have an hour if you get bit?
That's the bad part, yeah. So he suggested we not get bitten by snakes on this one.
Okay. I'll make a note of that.
Sorry, Eric, we were so excited to go, I forgot about you.
Eric Cotto from the Park Service monitors their hunt in the restricted zone.
What do we need to know about this place?
We have biters, stingers, and pokers out here. We have bees, we have Africanized bees, we have tarantulas, we have scorpions, we have rattlesnakes. So you definitely want to be aware of all that different type of stuff.
Those bees freak me out.
Just stay calm and just calmly try to leave them.
Well, enough about the bees. So let's head off on our adventure of many years in the making.
Let's find some rocks.
It's about time.
It's a brutal climb in one of the world's most forbidding deserts. The temperature is a nasty 104 degrees and rising.
You laughing at me?
No, I'm letting you get a little head start.
Oh, thank you. Why, because you need a breather?
No.
You know, you're the youngster. I'm the one who's supposed to have a hard time keeping up.
Well, I know. That's why I have you out in front pacing us.
Oh.
Because I know I won't leave you behind this way.
I know, you're always thinking about my welfare. Look at this old desert pavement. This looks great.
Why don't you make your little magnet stick out of a cactus branch or something?
No, that would be against the law, damaging a plant in the National Recreation Area. Eric, you know, we usually don't bring people along on our meteorite hunting trips.
Yeah,
it's only because you're special and because you're with the Park Service.
Awesome.
And also because we had to have you. No,
Thank you.
Just kidding.
Oh, cameraman down, cameraman down.
A crew member has gotten too close to the infamous jumping cholla cactus. At the slightest touch, its needles spring out and dig in deep.
It's tight. Try to get these needles out of you. I know it hurts, but...
Is there, are there any side effects?
It's pretty rare. You definitely want to keep an eye on it. The needles on cholla have sheaths, so when you go to pull them out, the sheath comes off, but the needle doesn't. Kind of tricks you.
I hope that connects through. I don't know.
Let's get up to the top of this peak over here.
Yeah.
I think we'll see what we need to go from there.
After 2 hours, they finally get to the top of the mesa, an area they've been dreaming about for years. The guys are convinced that this is the northern end of the strewn field, a 5,000 to 10,000 acre area that has never been searched. A big Gold Basin meteorite from here would make them legends and be worth a fortune.
The meteorite flew overhead, probably from south to north. We have circumstantial evidence. We know that meteorites have been found all down on the south side. So it seems improbable that the shower stopped on the south side of the lake. So one of our dreams has always been, can we get over the lake, up onto the bluffs and the mesas where probably no one's ever looked for meteorites?
And we're here.
Yeah, we're here.
I'm turning my detector on now.
Oh, thank you. I shall alert the media. What's that?
It's a 9.
Before they even take a step, Steve gets the first hit.
Yay, some wire. Nice find. I want some action. If we're correct in thinking that we're at the large end of the strewn field here, if we would expect to see bigger meteorites, but fewer of them and widely spaced. And so, I mean, there could be a half a mile or 2 miles in between the biggest meteorites out here. You could hike for days and just never come across it. So the odds are against us, but that doesn't mean we don't try.
Up here on this isolated mesa, the metal detector is the tool of choice. But it's how you use it that makes all the difference in meteorite hunting.
The detector almost acts as a second set of eyes, and the temptation is to follow it, but really, I need to let it go on its own and be looking for the round rocks, the fist-sized rocks, maybe bigger, ones that would be a little bit rusty, ones that just stand out a little bit. Ooh, look at the color on that one. Looks rusty. No attraction whatsoever. The definition of insanity, you know it's not a meteorite. The metal detector does not scream. The magnet does not attract. You stop and you bend down, you pick it up anyway, and you just try to keep sticking it to the magnet, and you know it's not gonna stick.
The shadows are getting longer. If they're going to find meteorite treasure today, they need to do it quickly.
Now it's a matter of just trying to get in as much time as left before sundown.
That's definitely what you want to hear. No, it's an earth rock. That was a big tease. Later for that. If there are meteorites out here, they might be very sparse. They might be very widely distributed. I keep wanting to go that way, further, further. Steve, I found the meanest meteorong in the history of meteorongs. Look, black. Ooh, what is that? Iron ore, I think.
How'd it
Probably.
here?
You see a dark black rock and bend over and test it with the magnet and it sticks and you go, oh, I've got one! And then actually you realize it's terrestrial iron ore. There are little crystals in there that we don't see in meteorites. And it looks like a bit of quartz as well, which we never see in meteorites. But that's pretty good meteorong. One of the better ones I've seen in a while, but it's not what we're looking for.
Faced with a long hike back down to the boat, the guys are forced to call it a day. A frustrating day.
Watch out for the burro. The burro stuff.
Back at the houseboat, Steve and Geoff discuss their plans for tomorrow. With just 1 day left on their permit and thousands of acres to cover, this decision is a tough one. Continue searching for big rocks in wicked terrain, or head back across the lake to where they know rocks have been found.
I guess somewhat tempting to go back up on the mountains. But I just feel we spent so much time. We must have put in nearly a 12-hour day, and we spent at least 4 hours getting up, hiking up, and 4 hours getting back with not that much time in the actual strewn field. What we haven't explored is this middle section of the strewn field, which was lightly researched by Jim back in the late 90s.
So how do we get out there?
It's a very rough road, but it's passable. You good for that?
Yeah.
All right.
Wake me up at sunrise. We made it up some really high hills, and there weren't any big rocks sitting out there waiting for us.
We've been to the small area. We were successful. We found numerous modest-sized pieces.
We just had one more day. We thought, you know, do we spend 75% of the day climbing up and climbing down and only having a little bit to look, or can we just go somewhere else where we can spend the rest of the day?
There's a big area in between the two zones that we've searched, so we've got a good chance for two reasons. One, the area's right. It should be in the medium-sized to big end of the strewn field. And two, no one should have hunted there. It's illegal.
8 hours left, and the pressure is on. The drive to location number 3, the center of the strewn field, is brutal. No paved roads, soaring temperatures, and every rock looks like a meteorite.
Hundreds or thousands of little fragments have been found over the years, but very, very few larger pieces have been found. By larger, I mean even larger than an orange. There must be some meteorites out here waiting for us somewhere.
When you see nothing and nothing and nothing hour after hour, you just get a little discouraged.
We got permission from the Park Service. They're extremely helpful and gracious to us. So sometimes everything can align for you and it just still doesn't work.
But when the stars do align, there's nothing like it.
Steve, I've got one!
Okay.
And here we go with the magnet. Sticks nicely to the magnet. Whoops, oh, fairly nicely. There's not a lot of iron in these. Look, there's some remnant fusion crust there. Woohoo! See, I get really grouchy when we don't find anything, and then as soon as I find something, I go, I love the Gold Basin, I love hunting here. And then an hour goes by and I haven't found anything. I'm like, oh, God, I'm gonna find the next piece.
As time dwindles, the decision to move to location number 3 proves to be a good one.
No way! Geoff!
What?
Got one!
Oh, fantastic.
Check it out. Here, let me see if you can see this thing. It's kind of over there.
Are you kidding me? Right there? I can see it from here. Holy cow.
Oh, yeah.
Look, there's another piece there. Or is that a second one? It's a piece. Is it a piece like that or a separate? Oh, that's amazing.
I bet it is.
It's a jigsaw puzzle meteorite.
Did you see it first, or?
I did.
I'm not surprised.
Half of this hilltop, it's impossible. I mean, unless it's under the detector, you're not going to hear it.
Well, I'll tell you one thing. No other meteorite hunters have walked over here.
No
Because
way.
you could not miss that.
No way.
That is really something.
Got some baggies.
Oh,
Looks
good.
like we're going to need more than one. 20 grams. That's number 1.
Ha. Is that a piece? Here.
Oh, yeah. 4.0.
This is so much fun. It's just sticking out of the ground.
We found a couple pieces, 12 inches away, and then some other pieces right nearby. So 15,000 years worth of winters, you're going to have a few contractions and expansions. So, but fortunately, it looks like it only affected a couple pieces up on the top.
Oh, more. Is that one?
Yep.
Oh, yeah.
10.4.
This is a great opportunity for us to try out this thing.
Okay.
This is the FLIR camera.
Uh-huh.
It's infrared, and it's going to allow us to test out another one of our theories.
Yeah.
That being, meteorites contain iron, they sit out baking in the sun all day. Will they heat up more than other rocks around them? And if they do, can we use an infrared FLIR camera to spot them?
FLIR works on the principle of heat signatures. If, for example, an object is hotter or cooler than the surrounding areas, those targets become more visible on the display monitor. Many police departments use this technology to catch criminals. If the same holds true for meteorites, the guys could get high tech on future hunts.
I just got this cold water from the cooler a few minutes ago. Is that still cold?
Yeah.
Put that next to it if you would. Oh my God. You can see the whole bottle really clearly.
Right,
It's just
yeah.
completely white.
If their theory that meteorites hold in the heat and will be hotter than everything else around them is correct, this meteorite should glow brightly using FLIR.
Can you point at the meteorite? The meteorite is appearing to not have a higher temperature than any of the surrounding rocks. I'm a bit surprised at that. If it worked, I thought we could walk around in strewnfields holding the camera.
Yeah.
And actually looking at the view screen.
No, I don't really see any difference.
Well, let's dig this thing up.
Oh, it's looking bigger.
It's getting bigger.
That's always a good sign.
The vast majority of meteorites found in the Gold Basin strewn field are only the size of a ping pong ball. Value around $100. On the surface, this rock appears to be at least the size of a baseball.
Holy cow.
Geoff.
Oh, you've got to be kidding me.
After 3 days of hunting in Gold Basin, Arizona, Meteorite men Geoff Notkin and Steve Arnold may have just hit pay dirt.
Wow, look at this.
Location number 3 in the center of the strewn field holds a space rock much bigger than most found here.
This is getting exciting. I'm very impressed by the size of this Gold Basin. This is one of the larger pieces I've seen. Do you think it's going to fall apart when you pick it up?
I hope not.
This meteorite is 4.5 billion years old, and extracting it is a tricky process. If it crumbles, this big, valuable space rock will be relatively worthless.
I know, I'm a bit worried about some of these fragments are going to fall off when we pull it out. Wow, the bigger it gets, the more it's worth.
Yeah,
For those of us who are financially motivated. Oh, I think it's ready for launching. Wow. It's a complete stone.
Look, and it's like solid on the bottom. It's just the top part here, where there may have been some cracks or freezing and thawing broke a couple pieces off, but it's mostly together. This rock's worth some bucks.
Okay, come on, I want to see it. Hand it over. Hand it over. Hand it over, I want to see it. Oh, it's heavy. Most of the gold basins are so weathered, there's just not that much iron left in them, but this is really heavy. This must be close to 1 kilo.
It's a cosmic softball. That makes the whole trip worth it.
You think?
Doesn't it? Yeah.
That is amazingly well preserved. Look, there's fusion crust on here.
Oh my, that is so distinct. And thumbprints. Little REGMAGLYPTs. So what do you think it's worth?
With this fusion crust and the thumbprinting, which is so rare on gold basins, I would say closer to 2,000. Oh, and then of course we have to add this on to the weight. There's another almost probably 80 grams here.
2,160.
Okay.
All right.
It's worth more than money.
It's priceless.
Well, fantastic job. Congratulations. That is a killer meteorite. This is a nice spot.
Yeah.
Let's collect a few stones. I'd left a photo and our rock hammers crossed in the symbol of an old mine. I think Jim would like that.
We wouldn't be out here if it wasn't for him. That picture, it just so captures who Jim was. His funny little hat, his earphones on, his garb and detector and holding a find. And it's a good memory to have.
With their permit expired, they pack up and head to Arizona State University. Before their 13 finds go on public display, the guys take them to ASU's world-renowned Meteorite Studies department for confirmation that they are, in fact, Gold Basin meteorites. As head of its collections department, Dr. Laurence Garvie will put their finds to the test.
So are they all fragments like this, or?
Well, these are fragments, but Steve has something very interesting to show you.
Oh, wow. A fairly large piece.
Yeah, and there were some more pieces dead as well.
Yes. It's amazing when you see something like this, you see the carbonate collar, so you know it was sitting in the ground for many, many years.
Oh, it was still in the ground.
Yeah, so that's what the carbonate collar tells you. Yeah. And actually, I hadn't noticed until, just turning the stone over, it's actually got some remnant fusion crust. It's actually a fairly fresh-looking stone, which is quite amazing because it's the bottom, that part that's in the soil has always been subjected to the moisture.
Under an optical microscope, Laurence takes a closer look at the fusion crust.
That's all fusion crust now. It's actually a good 2 millimeter thick, the fusion crust on this material.
And we always think of fusion crust as being so thin, like the thinnest rind on the outside of a meteorite after burning in the atmosphere. And this shows us that fusion crust can actually be comparatively thick.
Actually, I mean, it must be indicative of a fairly long or fairly low angle flight through the atmosphere.
We know that the fusion crust is fragile and typically decays away over time, and a lot of people have said no Gold Basin specimens have fusion crust, and we've always thought that some of them did, and now we have proof.
Absolutely. I mean, here's actually a higher magnification of one of those areas. You still see some of the original, almost fluid-like movement frozen in time. So even after 15,000 years of sitting in the ground, it's still been preserved. And I think that's quite amazing, actually.
But big rocks are not always better. A thin slice of find number 4, a smaller find, reveals incredible secrets frozen in time.
We see a whole range of beautiful chondrules. Whoa, look at that. That's beautiful.
You could blow that up and frame it.
Oh, absolutely. It's absolutely beautiful. These are meteorites that have chondrules. in them. Chondrules are the small glassy melt droplets that we often find in these meteorites. Come on, guys, you got to see this one. Well, this is the largest spherical chondrule in here.
It looks like the Death Star.
Yeah. Look at that, it's beautiful. Look at it, it's so distinct, it's just set in this matrix.
Spectacular.
That is spectacular. If you're thinking about the length of the age of our solar system, which is currently about 4.56 billion years, the chondrule formed pretty much right at the start of that. Oh, wow, look at that. Let's see, just get it in focus. It's not going to fit on the screen, it's so big. It's actually one that I've never seen before.
Amazing.
Look at that.
Good Lord.
I know. Wow. That is an amazing... In fact, there's a lot of barred olivine chondrules in this one. This thing's huge. I mean, it goes off to the side there, up here. Really? It's the whole thing. I mean, it's fairly flattened as well. So this was something fairly large that was incorporated into the meteorite at one point. But I've never seen a chondrule like that before. It's quite a spectacular example.
Hey, that's kind of cool.
It's
something he's never seen before.
That almost never happens.
This new chondrule could help scientists determine how the massive asteroid, the parent body of these Gold Basin meteorites, was formed billions of years ago.
And it shows that, there's still new things to be discovered, such as that really huge radial type chondrule that we found in the section. That's something that's unusual that needs to be studied. Yeah. I mean, the value in this one, what I like actually, is it actually shows fusion crust. So that adds, especially if you look at it like that, that adds a little bit extra to that piece.
So altogether, cash value, all the pieces on the table, $3,000, $3,500,
yeah,
$4,000. Do I hear?
I think 4,000 is the high side.
Not only are their finds Gold Basin meteorites, all combined, the stones are worth around $3,500, and they've yielded new scientific information.
This expedition was a success.
It's a dream come true for me to get up onto the North Shore, up onto the mesas. I've wanted to go up there for years and years.
I had a few good days in the strewn field on our limited window that we had with this permit, and we found some meteorites.
Laurence said inside one of the Gold Basin stones, he had discovered the largest chondrule he'd ever seen. That makes us feel like we're contributing to the scientific body of knowledge as well as having our adventures and finding rocks for ourselves.
Good memories. It's a good trip.